Hey everyone, welcome back to CAD4U. I am your host, Hale Gammons of CAD4U, and today we'll be just talking about two things. One being reviews of the print I made of the dog tag last episode, and two, also talking about a little bit of different types of filament. So, there's two different types of filament you can get. There is SLA filament and then solid filament. So, solid filament's what I've been using, and SLA is a resin, and we'll get to that later. So, here we go. There's the main ones used for 3D printing is ABS, PLA, nylon, and PETG. Those are the most common. And then there's also TPA, wood, metal, HIPS, magnetic, iron, conductive, kyber fiber, TPE, glow in the dark, amphora, PET, and then PVA, sandstone. There's a lot you can get. So the main two, like we said, is ABS and PLA. And PLA stands for polylactic acid, and then ABS stands for acrylonitrile butanen stearin. It's really weird. So, ABS, it's pretty cheap for a 2 pound roll. Excuse me. It's a high impact resistance, and it's strong, and it's a little bit flexible, but not like super flexible. It also is easy to extrude from a printer's nozzle, which works great, and it prints between 210 and 250 degrees Celsius. It's great for making automotive parts, moving parts, and kitchen appliances. Just like, fix it up, make your own stuff. It's also good for Legos. I actually made a couple Legos before myself. It's also used to make plastic wrap, water bottles, and cups. ABS not being used for 3D printing, and it's pretty cool. The high temp point is pretty cool, so it needs something to sit on the bed because it doesn't stick well by itself, so you need a hot heat bed for it. So the pros, like we said, is that it's durable and it's strong, it's lightweight and flexible, and it's pretty cheap. The cons are it's ABS is petroleum based, making it non biodegradable, and it needs a high temperature to reach its melting points. PLA filament, on the other hand, starting way cheaper. PLA, like we said, is polylactic acid. Um, it's like the easiest print stuff to print with. So it prints between 180 and 230 degrees Celsius. It's a low temperature 3D print. Excuse me. It's a lot of things you can use it for. A lot of people use it for surgical implants, um, including pins, rods, screws, and mesh. It's biodegradable, and it breaks down in the human body, and it can take anywhere between 6 months to 2 years depending on the part and its purpose. So this is a very good plastic for the medical field, which we will also continue talking about later. PLA filament is great for producing a whole range of consumer items, and one of the benefits is that it's faster to print than ABS, and it does not need a heated bed, and the end has a decent strength, durable, and some sort of impact resistance. Aside from 3D printing, PLA is used in food packing industries, disposable tableware, and diapers. Pros is that there's no harmful fumes, and it produces a sweet aroma when heated. It's easier to work with for beginners, and there's less warping that's tended to happen with it. And they also have it in like glow in the dark and translucent colors. The cons is that it's usually the main cause of jamming your nozzle, and it also gets a lot of moisture, which will make it more brittle and it'll be harder to print, and it's less sturdy. Then we have PET, which is a nice filament. It's a lot more expensive. It's almost $30 a roll for 2.2 pounds. So PET stands for polyethylene terephthalate. Phthalate, yes. It's a very popular 3D print. It's used everyday bottles, like they use it in everyday bottles, and it's 100% recyclable. Uh, when it's raw and there's no color, it's a crystal clear, and once it's exposed to cold or heat, it changes to a non-transparent transparency. Uh, it's used. The FDA actually approves it. PET, which is really nice. It's completely food safe. That means we can use it in cups, plates, and silverware. And the food industry uses it a lot. The pros is that it does not warp, shrink, and it's really flexible. It does not absorb moisture, and it does not degrade in water. And it's FDA approved, and the prices are actually getting lower. The cons is that it's not easy for people to work with, and the printer and the print bed needs to be fine-tuned for the best results. Continuing on, we're going to go to nylon. So nylon is where it gets expensive. It's $40 a roll. And nylon's something that I've been wanting to get into recently, but I just don't have the time and money for it. So it's also called Polymade, is another popular use in 3D printing. It's a synthetic polymer. It's stronger and more dense than ABS and PLA. The cost, it pays for itself essentially. It's flexible, light, and water and wear resistant. Not water, just resistant from wear. And it's less brittle. There's different types you can get between this type of strength and also the amount of flexibility in them. They print on a high temperature of 210 to 250 degrees Celsius, and it's used for consumer products and mechanical components and structural parts. It's pretty cool. Pros is that it's strong and durable. It's less brittle than PLA and ABS, and it's 100% thermoplastic material, and it can be remelted and used again without losing any bonding. The cons needs a high temperature, which means a more expensive 3D printer, because if you have a cheaper 3D printer, it tends to not go as hot. It breaks down and emits toxic fumes when heated, which is not really good, and it absorbs moisture. So these are the main filaments that I've used myself, but there is a filament called wood filament, which I believe, actually that's what I'm going to buy this Christmas. I'm going to get a roll or two, and I'll make a video for it still. It seems strange, obviously, that it would be wood, but it works really well because it's mixed of recycled woods and special binding polymer, and it looks like real wood when you're done printing too, which is incredible. So it prints between 200 and 260 degrees Celsius, which is a pretty high. I've seen a lot of people use it for like decorations, boxes, parts of tables and chairs and figurines, and it's really beautiful. Like there's pictures. I'll put a picture here from Imgur. It's a picture of it looks like an Xbox remote cover. It's a wonderful image. Here, let me just save it. And another thing that's really cool about this wood filament is that it actually contains wood fibers, and it produces unique wood objects, and it's easy to work with once you're done. The weak parts is that it's way softer than PLA, and it's less flexible, and it breaks easy. Metal filament, which is a PLA ABS mix, or it can start either row. It's really nice because it actually has a little bit of metal in it. So yeah. Though, and this is one other thing there's really nice I want to talk about. So it's called HIPS, or HIPS filament, and this stuff is actually dissolvable. So it's used for supports on 3D printer. I know MakerBot uses it a lot. It prints between 230 and 250 Celsius. And what they do with it is you can 3D print something that has a lot of overhangs and needs support, and you can put this around it, and then you can just toss it in water, and all the supports, which is the HIPS filament, will disappear. The pros is that it's easy to remove, and it's not toxic. The cons is that there's adhesion issues, and it doesn't work out without a heat bed. And they also have magnetic iron filament and conductive filament, but this stuff is less important because it's less used. Carbon fiber filament, on the other hand, is really nice, except that's really expensive. The pros about that is it's solid prints and there's no heat bed needed. The cons is it's expensive and it wears the nozzles, especially brass nozzles. And then there's TPE filament, which is extremely flexible. That stuff is really nice. And then they also have glow in the dark, which just got a little bit of a glow in the dark compound inside of it. And it's environmentally friendly as well, so you don't have to worry about it. So yeah, that's just the basic stuff on 3D printer plastics. The next type of filament we're going to talk about is actually liquid. It's a resin. It's a photosensitive mixture of monomers and oligomers. It's a short chain of carbon molecules that are combined into a lot bigger chains during the photochemical reactive change, and it becomes hardened plastic. So, how does it work? The build platform on an SLA 3D printer will be positioned in a tank of the liquid resin, and a UV laser creates a layer by layer, and it'll select the curves that you want to design, and using mirrors called gallops. These areas in the model are scanned to produce this part as well as possible. When the layer is finished, the platform moves a safe distance, and there's a little blade that'll recoat the surface with more resin. After printing this part, there's a no fully cured state requires further processing under UV light, with works really well. So as you can hear, that this SLA 3D printing takes a lot more work, but the quality of the 3D print is in just incredible. You look at it and it doesn't even look 3D printed. It just looks like a molded injection. And I'll throw a picture up or two up here, but it is incredible. And thanks to 3D Hubs, they have a really good explanation how it works with their pictures and everything. So I'll make sure to throw the link in the description as well for that. So some advantages about SLA, like the bottom down or bottom up desktop, so you can use it for people yourselves. It's low cost and it's pretty available, but the disadvantages is they're really small build sizes, and that means the materials also way smaller as well, and there's a lot more post processing work to do, and it's quite bad and toxic. So the max size that I have found myself that you can print up to is 145 by 175 millimeters on the build type, compared to an industrial, which is a very large build size and they have faster build times, where they can print up to 1500 by 7500 by 5500 millimeters, which is really weird numbers, but it's kind of weird. Um, so yeah, it works incredibly well, and the parts are just beautiful. Only thing that is a big problem is that there's curling and warping, same as FDM printing. And FDM, sorry, I didn't know if I mentioned that or not, but FDM printing is the plastic 3D printers that we just talked about, which is where they use a roll of plastic, not liquid. So, yeah, that's pretty cool. Um, the standard resin, there's different types of resin. There's standard, and there's castable, tough, and clear. So standard, it has a smooth surface, but it's relatively brittle. Clear is usually clear, obviously, and it requires uh, a lot of extensive work to clean it up for it to be really clear. Castable, it's used for creating mold patterns, and there's not many really cons about it. You're not really going to be using it for much. Um, Tough resin, it's like ABS and PP like mechanical properties, but it has very low thermal resistance, which is not really good. And there's high temperature resin, which is used for injected molds, but it's extremely expensive. And then there's dental resin, which is biocompatible and it's high abrasion resistant, but it's extremely expensive as well. And then there's rubber, which is a low dimensional accuracy, but it feels like rubber and it will move like rubber. So, yeah, post processing, a couple things you have to do is you have to buy UV light, which one is bad and it's not good for you. But one thing that's also really dangerous about SLA 3D printing is that the liquid itself, hold on, the liquid itself is really bad for you because it can actually irritate your skin and your eyes. So you don't want to be handling this stuff without gloves and goggles on, and it's really bad for you to breathe it in. If you're in an enclosed space like my office where I have my 3D printers, uh, it's not a really big deal with my printers because I don't print anything that has toxic fumes. And if I have, I would have felt it by now because I've had it for 5 years. So yeah. So yeah, it can irritate your respiratory system as well. That's why I need to be really, really uh, circulated room with air vent recommended to be open. So it's bad for you to eat it or swallow it or somehow get in your eyes. It's very toxic to water ecosystems. So we got to be careful with that. And it's also unstable in the curing process where you need to use the UV light or some sort of solution to clean it out. The UV light, it's bad for your eyes, like ultraviolet light's horrible for your eyes. So yeah. So the way to protect yourself, like I said, is wear gloves and goggles, and be in a ventilated area. Read all of the safety information before you work on it. It'll tell you all of it, and make sure you cure any of the resin that's left over that you're gonna throw away, because if something gets a hold of it or it spills outside, now you've just contaminated the ecosystem when it could have just been a solid piece of plastic. So that's the best way to go. So yeah. Also, try using resin until you run out of it, because that's another way to keep it from leaking in a trash dump or something. Just make sure that bottle's empty and rinse it out. So there we go. That's basically it on the two types of filaments you can use for 3D printing. And yeah. The final thing I'm going to be doing today is just a quick review on the dog's hat I made. I actually made it a little bit too big for my dog, and the little piece of tape is so you can't see the phone number. but I'm going to be making a little bit of a smaller one, and I'll post a picture on my Instagram. So without further ado, guys, let's end the video here, and we'll make another one next couple days. We got 2 more left, guys. Feel free to leave a comment and a like down below and tell me what's going up. Thank you.